Swayam Prabha. Digital India. Educated India.
Namaste and welcome back to the video course on watershed management. Today we will start a new module number 8 on stormwater and flood management. The topics covered in this module include stormwater management, design of drainage system, flood routing through channels and reservoir, flood control and reservoir operations, and some case studies. So, in today's lecture in module number 8, lecture number 31, we will discuss stormwater management. So, some of the important topics covered in today's lecture include stormwater runoff, harvesting, stormwater systems, integrated stormwater management, separate system, combined systems and urban flooding. So, keywords for today's lecture: stormwater runoff, system, harvesting, management and urban flooding. So, as we were discussing earlier, so when we deal with watershed management, so we have seen that there can be, say, sometimes plenty of water, say, due to heavy rainfall, or sometimes there can be drought type situations. So, depending upon the climatic conditions or the variations, say during monsoon season when heavy rainfall takes place, there can be say so much of water throughout the area, whether it is say rural area or urban area. So, especially in urban areas, when this water level goes up to certain, say beyond certain level, there will be huge problems like say disturbance to the traffic, disturbance to the total life in that area, and then a lot of, there will be huge losses, economic losses. So, that means say the flooding, say urban flooding is a major problem, say either on watershed scale or otherwise it is a major problem. So, this is caused due to the storm water, I mean due to the when the rainfall takes place, so as we have discussed earlier. So, we can classify into overland flow and channel flow. So, this overland flow component especially, say all this will be collected through drainage system, various drains, and then that will be joining to a stream or a channel, and then finally that will be routed through to the major river or to the ocean. So, that way only generally the system will be working. So, that way the stormwater management, especially when during the rainy season or monsoon season, the stormwater management within the watershed is an important topic, since it is say in many aspects it is related to the say the problems, that means like flooding problems, or it is related to the water harvesting, or whether we can capture some of this water and then recharge or do some harvesting. So, that way also it is important. So, in today's lecture, let us discuss about the stormwater runoff, stormwater management and then urban flooding related issues. So, as I mentioned, stormwater is rainwater and melted snow that runs of streets, lawns and other sites. So, that way say it is somewhat we can say it as a overland flow. So, whatever is say due to rainfall or due to melted snow say coming through the land and then coming to the streets and then lawns and other sites. So, this is generally termed as storm water. So, when storm water is absorbed into the ground, so you can see that wherever infiltration takes place, it is filtered and replenishes the aquifers or flow into streams and rivers. So, whether it can be either the storm water can be recharged to the aquifer systems through infiltration process, or it can simply flow through the drainage systems to the streams and rivers. So, this is say both way it is possible, but we want as much as possible if it is say infiltrating down. So, that replenishes the aquifer system, so that we can use in say for future purpose. So, by pumping out the water from the aquifer systems. And then when we consider the urbanized watershed or urbanized areas, say especially impervious areas like pavements and roofs prevent water from naturally soaking into the ground. So, you can see that in a city like Mumbai or Chennai or Calcutta or Delhi, we can see that most of the areas, say especially pavement, and then some other lot of other areas are also say paved, or it is impervious. So that way this impervious surface say stops the water to percolate down to the ground. So that way you can see that this water will be say moving fast. So this water runs rapidly into storm drains or sewer systems and drainage ditches, and then it can cause say lot of problems as we discussed. So some of the important problems can be like say downstream flooding. So if a huge heavy rainfall takes place, and then all this water, the storm water is coming say to the areas, so downstream areas, so then there can be possibility of flooding. Then stream bank erosion. So say especially say wherever the soil is loose, and then say heavy rainfall takes place, there can be stream bank erosion. And then wherever say especially this water will be going to rivers, and then it will be say many times this water will be taken back for say the say municipal water supply. So then there can be increased turbidity. So another issue can be increased turbidity. And then habitat destruction, changes in the stream flow hydrograph. So that means say especially in the urban areas, due to the less time of concentration, or time to peak will be less, and then the peak also increases. So that way there will be changes in the stream flow hydrographs. And then there can be combined sewer overflows. So wherever the sewage and then the stormwater drains are say single one, I mean combined system, there it can overflow, and then it can create when especially mixed with sewage, then there can be more problems, environmental problems. And then infrastructure damage, and then so all this can cause contamination of the surface water, like stream, rivers, ponds or lakes, and then also the coastal water bodies will be also affected by the polluted storm water. So that way we have to manage the storm water very scientifically, and then we should do appropriate plans, and then appropriate drainage system, and then say if we can treat this storm water to certain extent, so that the surface water will not be, or including the groundwater will not be polluted due to the polluted storm water. So that way we have to plan the system, the storm water system appropriately. So that way we can see that storm water management is very important topic when we discuss about the watershed management. So now this whether we can harvest this storm water, as we discussed, we were discussing about the rainwater harvesting earlier. So now the question is whether we can capture the storm water, which can cause otherwise various problems like flooding or the pollution to the surface water bodies. So if we can say harvest some of the water, and then either we can use it, or we can say infiltrate down to the aquifer systems. So then that will reduce the stormwater problems like flooding. So let us look say some important aspects related to stormwater harvesting. So stormwater concern for the volume and timing of runoff water. So that means flood control and water supplies and other related water pollution. So stormwater, as we discussed, it can cause flooding, and then it can be also cause surface water pollution. So that way stormwater, say as I mentioned earlier, it is also an important resource. So since this stormwater is not much polluted water, if we give some simple treatment like sedimentation, or like say settling tanks, through that kind of treatment we can directly utilize this stormwater. So stormwater is also a resource which we can readily use for various purposes. So say like techniques like stormwater harvesting with point source water management and purification can potentially make urban environment self-sustaining in terms of water. So, especially say urbanized watershed. So, we can see that when the urbanization increases, more water is needed. So, that way whatever water is available in that watershed may not be sufficient, if especially if this storm water is not harvested or storm water is not properly utilized. So, that way if we can collect this storm water and then either allows this storm water to recharge to the aquifer systems, or we can use to certain ways, then that will be very useful. So, stormwater harvesting is the collection, accumulation, treatment or purification and storing for its eventual reuse. So, storing can be either a direct storage like in a pond or in tanks, or it can be also we can recharge to the groundwater systems. So, that way the stormwater harvesting is very important, and it can also include other catchment areas from man-made surfaces such as roads or other urban environments such as parks, gardens and playing field. So, that way in all these areas say we can capture the stormwater and then say we can treat it properly, purify it and directly utilize it, or we can recharge to the aquifer systems. So, that way stormwater harvesting is a very important in terms of appropriate water resource utilization within a watershed. Now let us look into various aspects of stormwater management. So, as we have seen say especially in the rainy season say or monsoon season, we have got so much of storm water depending upon the rainfall condition. So, say we have to deal with large quantity of water, and then as we discussed there will be pollution problems also. So, we have to deal with the quality of the water. So, that way when we have to deal with the quantity and quality of the storm water, we call the process as storm water management. So, generally say we have to go for the best management practices. So, which is best possible as far as the stormwater management is concerned. So, the best management practice is often used to refer to both structural or engineered control devices and systems, say like retention ponds, or to treat polluted storm water say or say storage within a pond, as well as operational or procedural practices. So, this stormwater management is one of the best management practice. So, it can be for operational purpose or the procedural practices. So, there are many forms of stormwater management, and best management practices may include say manage the stormwater to control flooding and erosion, then manage and control hazardous materials to prevent release of pollutants to the environment, such as source control say from an industry or other sources. Then plan and construct stormwater systems so that contaminants are removed before they pollute the surface waters or the groundwater resources. So, we have to, when we look into the stormwater management, we have to deal two aspects. One is the quantity of the stormwater, second one is the quality of the stormwater. So, quantity is concerned, so that depends, mainly depends upon the rainfall pattern, the rainfall conditions. So, and then how effectively we can capture the stormwater and then use for various purposes. And then quality issues are concerned, say from where the pollution is coming, pollutant is coming and mixing with the stormwater, and then whether that will affect surface water sources like rivers, lakes, or other say surface water ponds and other things, or it may, this polluted water may infiltrate down to the aquifer systems and then also cause the pollution to the groundwater system. So, that way we have to see that best management practices are followed as far as stormwater management is concerned. So, that way we have to acquire and protect natural waterways where they still exist or can be rehabilitated. So, if it is say the development work is going on in natural say waterways areas, then say how we can do best management practices. So, like we can build soft structures such as ponds, swales or wetlands to work with the existing or hard drainage structures such as pipes and concrete channels. So, So, as far as stormwater systems, stormwater management is concerned, we can go for soft structures or we can go for hard drainage structures. So, soft structures generally in stormwater management we call ponds, swales or wetlands. So, that can appropriately collect the stormwater, and then so it will be automatically treated like sedimentation and say treatment within a wetlands. Or we have to go for hard structures like we can collect all this stormwater through pipes, channels, and then we can give appropriate treatments. Then we have to revise current stormwater regulations to address comprehensive stormwater needs. So, as far as say how we are effectively utilizing this stormwater, so depending upon that we can have appropriate rules and regulations as far as the stormwater management is concerned, and then we can enhance and enforce existing ordinances or laws to make sure property owners consider the effects of stormwater before and after development of their land. So, all this depends, say the whenever a watershed basis or an particular land device when we consider. So, it depends upon the developments taking place within that area. So, we should have certain rules and regulations as far as stormwater management is concerned, so that the private landowners or the property owners also they also go through these laws and then implement these rules as far as the stormwater is concerned. Then we have to educate a community about how its actions affect the water quality. So, most of the time as far as the private land owners or users, they may not bother about the water quality related to stormwater, but stormwater, say polluted stormwater is a major cause of water pollution. So, that way we should have strict rules and regulations, and then we have to implement these rules and regulations. So, that way we have to plan carefully to create solutions before problems becomes too great, especially in cities like Mumbai or Delhi and other areas. The urban stormwater pollution is a major problem, and then especially in places like Delhi where the groundwater is directly utilized back from the aquifer systems. So, that way when this polluted water infiltrate down to the aquifer system, the groundwater system will be also get polluted. So, that way we should be very careful to manage the stormwater with respect to quantity and the quality. So, now let us look why we have to manage the stormwater. So, as I mentioned, in urbanized areas, when urbanization progresses, then the impervious area also increases. So, that way that affects the stormwater. So, that way as I mentioned the pollution problem one aspect, and then the time of concentration and time to say the peak of the hydrograph will be increased with respect to natural watersheds. So, that way then so some of the problems like what can happen with respect to if you do not manage the stormwater appropriately, like road flooding can take place, and then related accidents, washouts, driver delays, etc. And then other issues like building and property flooding, say some of the buildings may get collapsed, or then property may be flooded, and then there will be structural and property damage. Then when this the stormwater say if it is going through the sewer systems, so then this water will come, there will backup will take place, and that will be another environmental problem. And then there can be problems like foundation settlements, then devalued properties, etc. So, that way as far as water quality is concerned, there will be major environmental damage. Then say many of the utilities will be affected. So, utility services interruptions like traffic interruptions, or the internet or telephone lines can be cut, or there can be related problems like that kind of interruptions can take place. Then increased cleanup costs. So, once say after the rainfall, all this, if these things are not done properly, then many areas will be, say, lot of mud will be there, lot of the solid waste will be on the road and other places. So, we have to spend more money for say cleanup after the rainfall events. And then related health hazards, and then personal inconvenience, then increased insurance costs. So, all these are all major issues related to stormwater if we do not appropriately manage the stormwater. So, some of the solutions can be, as we discussed, it can be soft solutions like ponds, salts, or wetlands, or we can have hard solutions like concrete, steel and SDP pipes, and then concrete structures, etc. So, where this water will be, the storm water will be appropriately collected and stored and then treated and then released appropriately. So, that is why we have to go for storm water management. So, and then also say, as we discussed, depending upon the rainfall condition, we have to manage large amount of storm water to avoid flooding and other inconveniences. And then traditional stormwater management design, say earlier, say general trend is we generally focus on collecting entire stormwater in piped networks like stormwater pipes, and then we transport this stormwater to say off-site and as quickly as possible, either directly and then we can either directly will be say discharged to a stream or river, say either with some treatment or without treatment, and then to a large stormwater management facility for if it is treatment is there, or a combined sewer system flowing to a wastewater treatment plant. So, that is where we have to say we have to effectively manage the stormwater, since the quantity may be higher and then the quality also we have to deal. And now in the say recent times, say in countries like United States of America, say there is certain terms like say as far as to deal with the stormwater related issues or urbanizing issues, say terms like low impact development or LID, and then wet weather green infrastructure. So, these terms have come into picture in the last few years, and these are say like as I mentioned, there can be hard solutions as far as stormwater management, or soft solutions like appropriate land management with respect to the construction of ponds or waste say wetlands, etc. So, this low impact development and wet weather green infrastructure, which these terms which are coming to say stormwater management in the last few years, this addresses the concerns through a variety of techniques, including strategic site design and then measures to control sources of runoff and thoughtful landscape planning. So, the main emphasis in the low impact development or the wet weather green infrastructure is mainly see the landscape planning, and then the main say emphasis on to treat the stormwater wherever it occurs, instead of carrying entire the stormwater to some centralized location and then treat it and then discharge to a river. Instead of that, we would like to deal with the stormwater at a local level, and it can be through landscape planning, or it can be some storage in some ponds or say in some wetlands, and then we should have appropriate plan. So, that way there are terms like low impact developments, LID, and then wet weather green infrastructure. These techniques are now in developing stage in countries like United States and Europe and then Australia, and so these are found to be very effective to deal with the stormwater related issues, and then overall environmental improvement have been observed in many of the small cities wherever this LID and wet weather green infrastructure things have been implemented. So, that way the main emphasis on say we are going for integrated stormwater management. It is not simply collecting the entire stormwater and then treating, but we are looking to an integrated system where the stormwater management is done by considering various aspects of the land use and then various other techniques. So, let us look into what is this integrated stormwater management. So, integrated so it is actually integrated water management only of IWM of stormwater. So, this address many of the issues affecting the health of waterways, water supply challenges facing the modern urban city. So, that way when we are effectively utilizing the say the water at local level wherever the storm water takes place, so actually we are reducing the water related problems, since readily say we will be recharging the water or we will be storing at local level, and that can be directly utilized. So, that way integrated water management of storm water known as low impact development in USA or water sensitive urban design WSUD in Australia. So, this integrated stormwater management is known as LID in USA or WSUD in Australia. So, IWM has the potential to improve runoff quality, reduce the risk and impact of flooding, and deliver an additional water resource to augment the potable supply. So, that the important terms here are, so we want to reduce the risk, and we want to say reduce the flooding problem, and then that will become a it will augment the potable water supply as far as the watershed is concerned. So, that way we are looking for development of modern city wherever the water needs will be met through these kinds of integrated water management. So, then altered runoff predicted by climate change has potential to increase the volume of storm water that can contribute to drainage and flooding related problems. So, that way we have to, so this integrated storm water management is a good option. So, we can reduce the problems like flooding or water quality issues, and then also we can improve the availability of the water on a local level, say by site management or say land use, land cover management itself. So, that way this is this integrated stormwater management is adopted in many countries nowadays. Say further, this IWM offers several techniques like stormwater harvesting, as we discussed, that reduce amount of water causing flooding. Then infiltration. So, infiltration means to restore the natural recharge of groundwater, and then biofiltration or bioretention. So, that means just like rain gardens, to store and treat runoff and release it at a controlled rate to reduce impact on streams and wetlands treatments. So, that way the biofiltration or bioretention is same through say by improving by making rain gardens or afforestations, by improving the plant covering, we can keep say the rainwater for some more time, and then it can be released in a controlled way, so that the flooding will be reduced and then local water availability will be improved. So, that way the integrated water management in its infancy, it is in infancy and brings together elements of drainage science, ecology, and the realization that traditional drainage solutions and transfer problems further downstream to the detriment of our environment and precious water resource. So, that way this integrated stormwater management is very important as far as the environmental management or environmental improvements, then that means the water quality improvement, and then also the water availability as far as the particular area is concerned. So, now let us have further discuss about some more aspects about this low impact development. Low impact development or LID aims to restore natural watershed functions through small scale treatments at the source of runoff, as I already mentioned, and the goal is to design a hydrologically functional site that mimics pre-development conditions. So, before the development what were the situations, so we want to keep to certain extent to that level itself by controlled developments and then various other means. So, that way this LID say in LID land development, mainly it is related to land development, and it works with nature to manage stormwater as close to its source as possible. So, we do not want to take this entire stormwater to some central locations and then treat it and then discharge to rivers, but local level we want to deal. So, that way it is land development issues, and then LID principles, the major principles are preserve and recreate the natural landscape features, and minimize the effective imperviousness to create functional and appealing site drainage that treat stormwater as source. So, this is the basic principle. So, we want to preserve and recreate natural landscape. Then some of the important practices as far as LID is concerned, as I mentioned, bioretention facilities, rain gardens, vegetated rooftops, rain barrels and permeable pavements. So, these are some of the practices which are adopted in countries like USA. And then this LID say water is managed in a way that reduces impacts of built up areas and promotes natural water movement. So, that is the essence of LID. So, we are looking for natural water movement, so that more recharge will be taking place and flooding will be reduced, and then there will be less possibility of water contamination. And then say another term as far as integrated stormwater management is concerned, green infrastructure. So, let us look into some more aspects of this LID and green infrastructure. So, as I mentioned, LID restores a watershed's hydrological ecological functions. So, as we discussed, and LID is a sustainable stormwater practice. So, that way the sustainability issues are there, and that will be kept within the watershed, and then environmental improvement also taking place. And then green infrastructure generally refers to the systems and practices that use or mimic natural processes to infiltrate, evapotranspirate, and then or reuse stormwater on the site where it is generated. So, that way by improving the vegetation cover or through various means within the area itself through green infrastructure, we are say trying to say increase the transpiration or evapotranspirations, and then we are also trying to reuse the stormwater, say by infiltrating down to the ground. So, green infrastructure generally used at a wide range of landscape scales in place or in addition to more traditional stormwater control elements to support the principles of say LID which we discussed. So, then say the another term related to green infrastructure is wet weather green infrastructure. So, this encompasses the approaches and technologies to infiltrate, evapotranspire, capture and reuse the stormwater to maintain or restore the natural hydrology. So, in all these LID or green infrastructure, the major emphasis is on the keeping the natural ecology with minimal developments, and then say give the possibility of more recharge to the grounds or to the aquifer systems, and then reduce the pollution. So, that way some of the benefits of LID and green infrastructure includes like benefits related to social, economic, environmental. So, social means it say reduction in urban heat islands effects, provide green jobs, green business opportunities. So, whenever these kinds of planning takes place, there are more jobs are created, and then education information provided through street kiosks, then crime reduction, health benefits through walking, biking, running trails, etc. So, there are some direct benefits and some of the indirect benefits also. And then economic benefits include energy cost reduction using wind powered lighting, then water conservation, then green enterprise business opportunities, etc. Then as far as environment is concerned, the total environment improvement will take place like carbon sequestration, improved water quality through 90% capture of stormwater, then carbon footprint reduction, recycling and beneficial use, etc. So, these are some of the benefits of LID and the green infrastructure as part of the integrated stormwater management. So, now say as we discussed, so all these practices it is better to do on a watershed scale, since watershed is the hydrologic unit as we were discussing in our lectures. So, when we are looking to stormwater management on a watershed basis, some of the important goals include like reduction of flood damage to life and property as we already discussed, then minimization of stormwater runoff from new developments, then reduction of soil erosion from construction activities, insurance of adequate stormwater facilities, then maintenance of groundwater recharge, then prevention or reduction of non-buoyant stormwater pollution, then maintenance of surface waters to ensure their biological functions, then protection of public health and welfare. So, like that number of goals we can set as far as the watershed based stormwater management is concerned. So, depending upon the area, depending upon the urbanization already took place, or how what pace the urbanization taking place, we can set our goals, and then we can try to achieve these goals. So, the main goal will be to capture the stormwater as much as possible quantity wise, and then keep the best quality possible, I mean to improve the water quality as far as the stormwater is concerned. And some of the important principles which we adopt for watershed based stormwater management include we can view the regulatory compliance as a minimum requirement for acceptance. Wherever rules and regulations are there, we have to see that they are implemented, and then requires a stormwater management plan considering watershed wide needs. So, when we consider the hydrology unit as watershed, the watershed based management, so then we have to see what are the other needs of the watershed. So, accordingly we can do the stormwater management. Then it also focuses on achieving good environmental results for the watershed in a cost effective manner. Then integrates stormwater plans into project developments and project features. Then uses collaborative partnership to leverage and then deliver a combination of watershed improvements, and then a coordinated mitigation or enhancement strategy. So, that way when we deal with watershed based stormwater management, we can with respect to the goals, we can adopt specific technologies which meet with the regulatory compliance, and then so that there will be improvement as far as the total environment on a watershed basis. So, that way when we look into the stormwater management, so let us now look into some of the important control measures. So, we can have various measures to deal with the stormwater. So, that way let us look into various approaches as far as the stormwater is concerned. So, the policies and source controls are concerned, it can be public education, land use planning, material management, etc. Then load level source controls are concerned, then we can look for green roofs, local storage or detention, stormwater harvesting, local infiltration, etc. Then community level stormwater control measures are concerned, we can go for community infiltration facilities, stormwater management ponds, constructed wetlands or natural wetlands. So, these are all structural measures. Actually, the policies and source control is concerned, it is non-structural measures. Then watershed level measures, it can be structural or non-structural depending upon what we are adopting or what kind of control measures we are going for. So, it can so the common approaches like manages water on a natural versus political boundaries, establishes water quality goals, and protects and then consider cumulative impacts, etc. So, we can go for various systems depending upon what kind of category we are looking for, or what kind of measures, like whether we are going for structural measures or non-structural measures. So, various norms, various approaches are possible. So, according to our goal, the set goals and specified principles and the compliance with respect to the regulations, we can choose appropriate approach for that location or for that watershed, like structural measures or non-structural measures, and then we can go for the stormwater management. So, this as far as stormwater is concerned, you see that when we deal with the urbanized watersheds, so say in the most of the urbanized areas we will have the sewage system, also we have to deal with the sewage systems, and then also we have to deal with the stormwater. So, in many cities, small or large cities, there can be separate system, one system for only to deal with the stormwater, and then another piping or other kinds of systems to deal with the sewage or the wastewater. So that way we can have, as far as stormwater management is concerned, we can have separate systems, or we can some cities or some areas, especially third world countries, we can see there can be combined systems. So, where both the sewage systems or the wastewater and storm water, only one system is given, that kind of system is called the combined system. So, let us look into some aspects of the separate system and combined system. So, in the separate system, the polluted storm water runoff we transport through municipal separate storm sewer systems, from which it is often discharged untreated to local water bodies. And then to prevent harmful pollutants from being washed or dumped into water bodies, we can also go for appropriate pollution control measures. And separate systems are comprised of two independent piping systems, one system for sanitary or the wastewater and another for the storm water systems. So, you can see here in this the layout. So, if these are some of the urbanized areas, and then storm water is concerned, it is now separately collected and then it is directly discharged to a river like this. And then the wastewater is concerned, it is all collected through the pipelines, and there will be a treatment facility like this, and then after treatment it is discharged to the river or the stream. So, that is the basic principle of separate systems. And now, let us look into the combined system. The combined sewer system conveys both the sanitary sewage and storm water in one piping systems. During normal dry weather conditions, sanitary waste collected in the combined sewer system are diverted to the wastewater treatment plants, and during the periods of significant rainfall, the capacity of a combined sewer system may get exceeded. Let the that is so called excess flow. So, this is a mixture of storm water and sanitary waste, and this directly discharged into large water bodies, or sometimes say this excess flow we call it as combined sewer overflow. So, the system is like this. So, say when there is no rainfall, so the entire wastewater is collected, and then it will be collected like this, and then it will be treated at this location, and then it will be discharged to the river or stream. And then say during the rainfall season, there will be this sewage water or the sewage or the wastewater and the storm water will be coming, and so you can see a mixed combination of storm water and wastewater will be there, and that will be discharged to the so it say depending upon the condition, it may be treated, or without treatment also sometimes it will be discharged to the streams or rivers. So, this is so called combined systems. So, that way what we are discussing is how to manage this storm water, and then say whether it is say combined system or separate system. So, that way we have to either say collect through pipelines or the open drains, and then it can be after treatment or without treatment it will be discharged. So, now let us look into what are the effects of this, say if we do not manage the storm water properly. So, as we discussed, the main effect will be the flooding problem. So, let us look into the urbanization effects and the flooding problem. So, say as we discussed, whenever say urbanization takes place within a watershed, so many structures will be constructed, roads will be constructed. So, the natural surface is covered by artificial structures. So, that way it increases impervious areas, and the channel characteristics of shape like shape, slope, roughness, these are all better known as far as the urban areas are concerned. And there will be changes in flow pattern, and the quality of runoff will be also influenced. And then say the losses are concerned, like infiltration losses we can sometimes neglect. So, estimation of losses become simplified. So, but this may lead to higher peak flow and then shorter time to peak, and causes the flooding at the low lying areas and undesirable load to the downstream areas. So, you can see that if there is no urbanization, that means a natural watershed. So, generally, so if you plot the hydrograph, that means time versus discharge, you can see that say rural watershed where is not much urbanization, it will be the hydrograph will be a flattened graph like this, and the peak will be at this location. But if the same location, if urbanization takes place, then we can see that this hydrograph peak will be increased like this, and then time to peak will be reduced. So, that way we can see that what happens, say the time of concentration is reduced. So, the time to peak is less, and then huge quantity of water will be coming to the drainage systems or to the streams or to the river, and then that will rise the water level, water depth, and then finally the flooding will be the effect. So, the main urbanization effects will be like say the peak of the hydrograph or the discharge will be increased, and then time to peak will be reduced. So, that way there will be within a short duration there are possibility of flooding. So, that is the main effect of urbanization. So, there can be this urbanization, due to urbanization and then its flooding, urban flooding, there can be number of reasons or number of causes. So, some of the important causes are listed here. So, the causes can be due to meteorological factors, hydrological factors or human factors. So, the meteorological factors like rainfall, cyclonic storms, small scale storms, temperature increase, snowfall and snow melt. And then hydrological factors can be soil moisture level, groundwater conditions, infiltration, impervious cover, channel conditions, tidal effects, etc. And then human factors like say changes in land use. So, urbanization means actually what is happening is a change in land use. So, land use, land cover changes, then inappropriate drainage systems. So, there is no effective drainage systems or the drainage system is not effective. Then occupation of floodplain areas. So, like wherever the floodplain areas that is say buildings are constructed or it is encroached. Then sudden release of water from dams due to the heavy rainfall conditions, then climate change effects, urban microclimate or indiscriminate waste disposal. So, these are some of the causes of urban flooding. So, now say as we discussed say main issue is say the flow depth increases and time to peak is reduces. So, that way so sudden flooding can or flash flood can takes place. So, now let us look what are the problems related to urban flooding. So, in this slide the impacts may include loss of money, temporary disruption to transportation systems or the telecommunication systems, then inconvenience to city life, and then it can also cause erosion and instability of soils on steep slopes threatening houses. So, there can be landslide and other related issues. Then the extreme events results in inundation for a prolonged duration, then heavy rainfall, tidal influences and lack of adequate drainage system. So, these are all some of the serious problems affecting especially in coastal areas. So, they say simultaneously with heavy rainfall, if the tidal level also rises in a city like Mumbai, then you can see that there will be heavy flooding problems, and then that will be prolonged flooding as happened in 26 July 2005. So, due to the complexity of this problem, so whenever we deal with urban flooding or urban flood prediction, we need sophisticated tools like geographic information system and data we may have to get from remote sensing, and then very complicated numerical methods like finite element method or finite difference techniques we have to utilize to see whether the flooding possibilities and other things. So, urban flooding major issues are loss of life, say economic loss, then say disturbance to the transportation and the telecommunication systems. And then also say the urbanization impacts, say there can be modification of say flooding characteristics say will be modified by introducing the storm drains in many of the urban areas. Then rapid removal of water from the drain area takes place as we discussed, since the time and infiltration decreases, and to delay the peak rate of runoff increasing and in the area of storage capacity and delaying outflow. So, we can have the possibility of say detention ponds, so that all this problem can be reduced, and runoff from streets to drainage system takes place directly instead of through the drainage systems, and flooding takes place since limited intake capacity of the drainage system and insufficient capacity of the say if it is piped system, so insufficient capacity of the piped drainage systems. So, to deal with say the urban flooding problems, say we can say in urban hydrology there generally two types of approaches are used. First one is empirical lumped parameter approach. So, in the empirical lumped parameter approach, so we consider the entire drainage area as a single unit, and then we estimate the flow at only at the most downstream point or the outlet of the watershed. Then we assume the rainfall is uniformly distributed in time and space over the entire watershed, and then we can have a technique like unit hydrograph or instantaneous unit hydrograph techniques, and then we can see that how the system is behaving. So, other approach is called a physical process approach. So, in the physical process approach, say we have to determine, say, or we have to go for appropriate design of this stormwater system. We deduct losses from the design storm to arrive at an excess rainfall rate, how much is the excess rainfall taking place, and then we can determine the flow to gutter or the drainage systems, and then we can route through this gutter to the main channel, and then say we can use say we can route the flow through the principal conveyance systems, and finally we can determine the outflow hydrograph. So, accordingly, say depending upon the outflow hydrograph at the outlet of the watershed, we can go for design or we can go for the management of the system which we consider. So, now what we are discussing is about the stormwater management and urban flooding related problems. So, when we deal with say the various measures say to delay, so we can say we cannot completely control the storm runoff, or we cannot totally say deal with the entire systems. So, we can generally we can reduce or delay the storm runoff. So, that number of measures are available, like some of the say measures which we can utilize include large flat roofs, then porous parking lots, then increase recharge, then planting a high delaying grass, then increase forest cover, then detention basins, grassed waterways, porous sidewalks, then rooftop gardens, fountain storage, etc. So, in all this what we are trying is say we are trying to delay the movement of the storm water, and then say we are trying to say infiltrate down some of the portion of this the storm runoff, and then say we are trying to delay the movements of the runoff, so that say the time to peak will be increased, and the peak also will be reduced as far as the urban storm runoff is concerned. So, before closing this lecture, let us look into a case study related to the stormwater drainage for an urban area. So, the study area is a housing colony in Santa Cruz, Mumbai. So, here the aim is to study the actual situation of the flooding problem in a low-lying urban area subjected to tidal effects, and suggest measures. So, presently the area is affected with the frequent flooding. I mean, say this study we have carried out in 2006. So, there were heavy flooding in 2005 itself. So, present status of the drainage system, two submersible pumps which pumps this storm water to outside drainage system, and then there is a 900 mm diameter pipe say draining directly to a nearby river called Mithi river. So, this is the area. So, you can see that here say for this entire area there is a major drainage system going to the Mithi river here, which will be joining to the Arabian Sea, and say here say the existing system was there was a drainage system which is joining here, and then there was a 900 mm pipe which is taking all this storm water from the area. But due to the heavy rainfall conditions, say for example in 2005 July 26, this entire area was flooded for few days, and then the housing colony came to us to see the remedial measures. So, here the two issues are there. One is the main say flow taking place within the area, and then also the tidal rise what is happening within this river system, and then that will be the backflow coming to the area. So, when the water level rises in the river and high tide occurs, the outfall of drain is subjected to tidal effects and consequent flooding. So, during the year 2004 a new 900 mm diameter pipe has been constructed, but in 2005 as I mentioned again there was flooding. So, here we analyzed the system say hydrologically and then hydraulically also. So, our analysis showed that the stormwater discharge through the pumping is about 0.051 meter cube per second, and the stormwater discharge through the 900 mm diameter pipe was 0.492 meter cube per second, and total drainage that way the capacity is 0.543 meter cube per second. So, we used to here rational formula Q is equal to CIA, and runoff coefficient has been considered as 1. And so, accordingly we found that this say drainage system is effectively useful only up to a rainfall of 25 mm per hour. But many times the rainfall exceeds, many years the rainfall exceeds, say it can be 50 mm per hour like that. So, during the monsoon, as I mentioned, river overflows, and addition the heavy rainfall happens. So, simultaneously the reverse flow occurs, and that is the main issue here. So, the problem in selecting the design criteria like unavailability of adequate natural slope to facilitate gravity flow, then tidal effects encountered at the exit points, then lack of space to provide appropriate drainage system. So, these were some of the problems in this area. So, then we analyzed hydrologically and hydraulically. So, various rainfall conditions like 25 mm per hour, 50 mm per hour, 100 mm per hour. So, like say like a 2-year return period, say 5-year return period, then say 10-year return periods like that, up to 50 years return period like 100 mm per hour, and then this shows the measured rainfall intensity, and this shows the stormwater discharge. So, and then we did the hydraulic analysis using the Manning's equations. Q is equal to A into R to the power 2 by 3 S to the power 1 by 2 by N, where N is the Manning's reference coefficient, A is the drainage sectional area, R is say hydraulic radius, A by P, P is the wetted perimeter, S is the slope. So, there we use this hydraulic analysis to suit say for example at least 50 mm per hour if the rainfall intensity takes place, how we can effective design. So, that way what we identified through this study is the present existing ground level has to be increased at least 60 centimeter in the lower levels of the low lying area, so that adequate slope is available. Then a small gutter all along the internal road of the area leading to the lowest point should be given. Since the existing 900 mm pipe is almost at ground level, it is advisable not to have cross connection to this. Then entry of stormwater from the surrounding areas needs to be prevented. Then the cross connection to the nearby draining nalla has to be cut off. So, these were some of the recommendations as far as the this study area is concerned. So, that way we did the hydraulic analysis, and then we come up with certain recommendations to reduce the urban flooding problem in this area due to the stormwater. So, before closing some of the questions like tutorial questions, critically study the stormwater management issues in India. What are the major problems in implementing appropriate stormwater management systems in Indian cities like Mumbai and Calcutta, and then you can compare with what is the systems in USA or UK, and then come up with a better proposal for Indian stormwater management for Indian cities. Then some few self-evaluation questions, discuss stormwater runoff parameters influencing on watershed basis. What is the best management practices related to stormwater management? Discuss the integrated stormwater management practices. What are the goals and principles of watershed based stormwater management? Differentiate between separate and combined stormwater management systems. Then what are the important measures for delaying storm runoff? So, few assignment questions, illustrate various stormwater harvesting techniques, why we have to manage stormwater, discuss the features of low impact development and green infrastructure within the perspective of stormwater management, illustrate important stormwater control measures, what are the important effects of urbanization on runoff, discuss the important causes of urban flooding, differentiate between empirical lumped parameter approach and physical process approach in urban hydrology. All these questions you can answer by going through today's lecture. So, before closing down, one unsolved problem, what are the important stormwater management problems in your watershed area? Collect the necessary data for the stormwater design in your area with the help of rainfall data, topo sheets and other maps such as drainage network maps, land use land cover map, road network, design an effective stormwater management plan for your study area. So, as presented the case study, you can solve, say for your study area, you can come up with a typical design to deal with the stormwater management issues. So, today what we discussed is stormwater management. So, in the next lecture we will be discussing about the drainage design and related issues as far as say the stormwater system is concerned. Thank you.